Welcome to a peaceful journey through the hidden world of mushrooms. For the next little while, let's wander together through forests, meadows, and the secret places where these remarkable beings dwell. Settle in, breathe deeply, and prepare to discover 100 fascinating truths about the mushrooms that quietly shape our world. Let's start with something that might surprise you. When you see a mushroom pushing up through the forest floor, you're not actually looking at the whole organism. What we call a mushroom is just the fruit, like an apple on a tree. The real organism lives hidden beneath the surface, spreading through the soil in a vast network of thread-like structures called mycelium. These delicate white threads can stretch for miles underground, connecting trees, breaking down dead matter, and forming one of nature's most elegant networks. And here's something even more remarkable: mushrooms aren't plants at all. For centuries, we grouped them with the green growing things around us, but they belong to their own kingdom entirely, the kingdom fungi. They're actually more closely related to you and me than they are to the plants they grow beside. While plants create their own food through photosynthesis, mushrooms, like us, must consume organic matter to survive. There are estimated to be somewhere between 2.2 and 3.8 million species of fungi on Earth, though we've only identified about 150,000 of them so far. Imagine that, millions of species still waiting to be discovered, living quietly in soils and forests we walk through every day. Each one playing its role in the grand story of life on our planet. Consider the age of fungi for a moment. The first fungi appeared on Earth roughly 1 billion years ago, long before the first plants ventured onto land. They were pioneers of the terrestrial world, and they may have even helped those first plants make the leap from water to land. Around 450 million years ago, fungi formed partnerships with early plants, helping them extract nutrients from barren rock and soil. Without this ancient alliance, the green world we know today might never have existed. Now, let's talk about how mushrooms reproduce, because it's quite unlike anything else you might expect. Instead of seeds, mushrooms release spores, microscopic cells so tiny that a single mushroom can produce billions of them. A large mushroom might release up to 1 trillion spores in its lifetime. These spores drift on the wind, each one carrying the potential for new life, traveling sometimes hundreds of miles before landing in a place where they might take root and begin again. The variety among mushrooms is staggering. Some glow in the dark with an eerie green luminescence, a phenomenon called bioluminescence. Over 70 species of fungi produce their own light through a chemical reaction. In dark forests, these glowing mushrooms once served as natural lanterns, helping travelers find their way along paths. The mechanism is similar to how fireflies light up summer evenings. Mushrooms can also be incredibly fast-growing. Some species can grow several inches in just a few hours under the right conditions. There are documented cases of mushrooms pushing up through asphalt, demonstrating a quiet but remarkable strength. This rapid growth is possible because the mushroom isn't building everything from scratch, it's simply inflating cells that already exist in the mycelium below, pumping them full of water until they expand and push upward into our world. Perhaps most fascinating of all, mushrooms have been on Earth longer than trees. When the first trees appeared around 350 million years ago, they faced a problem: nothing could break down their tough, woody tissue after they died. For tens of millions of years, dead trees simply accumulated. Then fungi evolved the ability to decompose lignin, the tough compound in wood, and suddenly the carbon locked in those ancient forests could be recycled. Some scientists believe this moment, when fungi learned to break down wood, marks the end of the Carboniferous period and the formation of many of our coal deposits. As we continue our journey, let's explore the remarkable ways mushrooms interact with the world around them. Deep in the forest soil, something extraordinary is happening. The mycelium of mushrooms connects with the roots of trees, forming what scientists call mycorrhizal relationships. This partnership exists in about 90% of all plant species on Earth. The fungi extend far beyond where the tree's roots can reach, gathering water and nutrients from distant soil, particularly phosphorus and nitrogen, which they deliver to the tree. In exchange, The tree provides the fungus with sugars created through photosynthesis. It's a fair trade, refined over millions of years, and it's happening right now beneath nearly every tree you see. But the connection goes even deeper than a simple exchange. These fungal networks actually link multiple trees together, creating what some researchers call the wood wide web. Through this underground network, trees can share resources with one another. A mother tree, large and well established, can send nutrients through the fungal network to her offspring growing in the shade below. Even more remarkably, when one tree is under attack from insects, it can send chemical warning signals through the mycelium to neighboring trees, allowing them to activate their defenses before the insects arrive. The largest living organism on Earth is actually a fungus. In the Blue Mountains of Oregon, a single honey fungus, Armillaria ostoi, stretches across 2,385 acres of forest. This individual fungus is estimated to be between 2,400 and 8,650 years old, making it not only the largest but also one of the oldest living things on our planet. It grows slowly, spreading through the soil at about 3 feet per year, a patient giant hidden beneath the forest floor. Now, consider the role mushrooms play in medicine. For thousands of years, humans have used fungi to heal. But it wasn't until 1928 that we stumbled upon one of the most important medical discoveries in human history. Alexander Fleming noticed that a mold, Penicillium notatum, had contaminated one of his bacterial cultures, and in a ring around the mold, the bacteria had died. This chance observation led to the development of penicillin, the first widely used antibiotic. It's estimated that penicillin and its derivatives have saved over 200 million lives. A simple fungus, quietly growing, holding within it the power to transform modern medicine. Mushrooms are also master chemists. They produce thousands of different compounds, many of which we're only beginning to understand. Some mushrooms create antibiotics, some produce compounds that suppress the immune system, which proved crucial in making organ transplants possible. Others create substances that can lower cholesterol, fight viruses, or even combat cancer cells. The shiitake mushroom, for instance, contains a compound called lentinin, which has been approved as an anti-cancer drug in some countries and is known to boost immune function. Let's talk about the incredible strength of mushrooms in another sense, their ability to break down toxins. Some species of fungi can actually clean up environmental pollution, a process called mycoremediation. Certain mushrooms can break down oil spills, absorbing and digesting petroleum products. Others can remove heavy metals from contaminated soil, concentrating them in their fruiting bodies where they can be safely removed. Oyster mushrooms have been used to break down cigarette butts, and some fungi can even degrade certain plastics and pesticides. They're nature's recyclers, capable of transforming poison into harmless compounds. Here's something that might change how you think about soil itself. In just 1 teaspoon of healthy soil, there can be several miles of fungal filaments. These microscopic threads are so fine that they can squeeze between soil particles, binding them together and creating soil structure. Without fungi, our soils would be loose, powdery, unable to hold water or nutrients effectively. The very ground beneath our feet owes its character to the quiet work of countless fungi. And finally, consider the speed at which mushrooms communicate. Recent research has discovered that fungi generate electrical impulses that travel through their mycelial networks, somewhat like neurons firing in a brain. These impulses seem to spike in frequency when the fungus encounters food or obstacles. While we're only beginning to understand this phenomenon, it suggests that fungi process information about their environment and respond to it in ways more complex than we ever imagined. The forest floor, it turns out, is alive with silent conversation. Let's journey now into the relationship between mushrooms and humanity, a connection as old as our species itself. Mushrooms have been part of human culture for far longer than recorded history. In 1991, hikers in the Alps discovered the frozen remains of a man who lived 5,300 years ago. Among his possessions were 2 types of mushrooms carried on leather strings. One was a birch parley paw, likely used as medicine for parasites. The other was amadou, a species used to carry fire. This ancient traveler, whom we now call Otzi the Iceman, understood what traditional peoples around the world have always known. Mushrooms are powerful allies in survival and healing. In many cultures, certain mushrooms hold sacred status. Indigenous peoples of Central America have used psilocybin mushrooms in spiritual ceremonies for thousands of years. The Mazatek people of Mexico refer to them as little saints and use them to communicate with the divine, to heal, and to seek guidance. Rock art in Spain and Algeria, dated to 6,000 years ago, appears to depict mushrooms in ritual contexts. These aren't mere traditions. Modern research is now confirming that compounds in these mushrooms can indeed have profound effects on human consciousness and have shown promise in treating depression, anxiety, and addiction. Here's a fact about mushroom diversity that might astonish you. Mushrooms come in nearly every color imaginable. There are mushrooms as white as fresh snow, others that glow with brilliant orange or red. Some are deep purple, others bright yellow. There's even a mushroom called the indigo milkcap that bleeds bright blue liquid when cut. And then there's Entoloma hoaxtetri, a small mushroom from New Zealand that's so vividly blue it appears almost unnatural, like something from a fantasy world. Each color often serves a purpose, whether attracting animals to spread spores or warning predators that the mushroom is poisonous. Speaking of poison, some mushrooms are among the most toxic substances known to nature. The deathcap mushroom, Amanita phallodes, is responsible for about 90% of mushroom-related deaths worldwide. Just half a mushroom cap can be lethal to an adult human. What makes it particularly dangerous is that symptoms don't appear for 6 to 24 hours after eating it, by which time the toxins have already begun destroying the liver and kidneys. Yet this same mushroom looks quite innocent, even resembling some edible species, which is why foraging for wild mushrooms requires deep knowledge and careful attention. But mushrooms aren't just dangerous or medicinal, they're also deeply nutritious. They're one of the few non-animal sources of vitamin D, which they produce when exposed to sunlight, much like human skin. Mushrooms are rich in B vitamins, selenium, potassium, and copper. They contain powerful antioxidants, including one called ergothioneine that some scientists believe may be essential for human health. Despite being about 90% water, mushrooms pack remarkable nutritional density, offering protein, fiber, and minerals while being naturally low in calories and fat. Now let's consider something truly microscopic yet monumentous. Fungal spores are so resilient that they can survive in the vacuum of space. Scientists have exposed them to cosmic radiation, extreme temperatures, and the airless void beyond our atmosphere, and still some spores remain viable. This remarkable hardiness has led some researchers to seriously consider the possibility of panspermia, the theory that life or its precursors might travel between planets on asteroids or comets. Could Earth's fungi have originated elsewhere in the cosmos? It's a question that pushes the boundaries of our imagination. Mushrooms also have an unexpected relationship with climate. As decomposers, they play a crucial role in the carbon cycle. When fungi break down dead organic matter, they release carbon dioxide back into the atmosphere. But the mycelium itself stores carbon in the soil, and mycorrhizal fungi help sequester carbon in forest ecosystems. Some estimates suggest that mycorrhizal fungi help forests store up to 70% of the carbon they capture. As we grapple with climate change, understanding and protecting these fungal networks becomes not just scientifically interesting but critically important for our planet's future. And here's one more wonder to contemplate as we prepare to move forward. Mushrooms have been to space themselves. In the 1990s, cosmonauts aboard the Mir space station noticed something troubling. A species of fungus was growing on the station's equipment, actually eating the plastic, metal, and glass. This wasn't contamination from Earth, but rather fungi adapting to survive in space, finding nutrients in materials we never imagined they could consume. It demonstrated once again the incredible adaptability and resilience of these remarkable organisms. As we venture deeper into the world of mushrooms, we discover layers of complexity that reveal just how interconnected all life truly is. Let's begin with something that exists at the very edge of our perception. The largest mushroom ever recorded was a termite fungus found in the Democratic Republic of Congo. Its cap measured over 3 feet across, with a circumference of nearly 16 feet. Imagine encountering such a giant rising from the forest floor, a monument to the hidden organisms sprawling beneath it. Yet even this giant is dwarfed by the underground networks from which it springs. Mushrooms have an intricate relationship with insects, and nowhere is this more fascinating than with certain species of ants. Leafcutter ants don't actually eat the leaves they harvest. Instead, they carry them underground to cultivate fungus gardens. These ants are farmers, and they've been practicing agriculture for about 50 million years, long before humans discovered it. The ants carefully tend their fungal crops, removing contaminants, providing fresh leaf material, and even using antimicrobial secretions to protect their gardens from disease. The fungus, in turn, breaks down the leaves into nutrients the ants can digest. Neither can survive without the other. Here's something about timing that reveals nature's precision. Many mushrooms appear only at specific times of year, triggered by particular combinations of temperature, moisture, and even day length. Some species fruit only in spring, others in the cool dampness of autumn. Matsutake mushrooms, prized in Japanese cuisine and worth hundreds of dollars per pound, appear for just a few weeks each year. This precise timing evolved over millennia, ensuring that spores are released when conditions are optimal for their survival and dispersal. Now consider the sheer variety of shapes mushrooms take. While we often picture the classic umbrella shape with a cap and stem, mushrooms can look like coral, shells, birds' nests, stars, golf balls, or even delicate cups. There are mushrooms that resemble honeycomb, others that look like tiny icicles hanging from wood, and some that form perfect spheres. The stinkhorn mushroom emerges from an egg-like structure and unfolds into shapes that can look remarkably like, well, their name suggests. Each form evolved to solve the problem of spore dispersal in different environments. Speaking of dispersal, some mushrooms have developed truly ingenious methods. The bird's nest fungus creates tiny egg-shaped structures sitting in a cup-like nest. When a raindrop hits the nest at just the right angle, it catapults these eggs up to 6 feet away, where they stick to nearby vegetation. Animals then eat the vegetation, and the spores pass through their digestive systems unharmed, spreading across the landscape. It's a solution that combines physics, chemistry, and biology in elegant harmony. Mushrooms also have remarkable longevity, beyond even the ancient honey fungus we mentioned earlier. Some bracket fungi living on trees can persist for decades, adding a new layer of growth each year like the rings of a tree. Scientists have found individual bracket fungi over 70 years old, silent witnesses to generations of forest life unfolding around them. Each year's layer tells a story of the conditions that year, whether it was wet or dry, warm or cold. Let's turn our attention to something quite unexpected: mushrooms making rain. Research has shown that fungi release massive quantities of spores into the atmosphere. These spores can act as nuclei around which water vapor condenses, forming clouds and, eventually, rain. In the Amazon rainforest, fungal spores may be responsible for a significant portion of rainfall. The mushrooms beneath the trees help create the very rain that sustains the forest, a perfect cycle of giving and receiving. Here's a fact about mushroom intelligence that challenges our assumptions. Although they lack brains or nervous systems, fungi demonstrate problem-solving abilities. In laboratory experiments, slime molds, which are fungus-like organisms, have been able to navigate mazes, finding the shortest path to food sources. When researchers recreated the Tokyo subway system using food sources positioned like stations, the slime mold created a network nearly identical to the human-designed system, which took years of planning and engineering to develop. The slime mold found this solution in hours, optimizing for efficiency with no central control, just the simple rules governing its growth. Mushrooms are also masters of transformation. Some species can break down crude oil into harmless compounds. Others can digest explosives like TNT, rendering them inert. There are mushrooms that can consume radiation, actually thriving in radioactive environments. After the Chernobyl disaster, scientists discovered fungi growing on and within the damaged reactor, using melanin to convert gamma radiation into chemical energy, much like plants use chlorophyll to convert sunlight. These radiotrophic fungi suggest possibilities we're only beginning to explore. And finally, consider this: mushrooms may have helped humans evolve. Some anthropologists have proposed the stoned ape theory, suggesting that early human ancestors' consumption of psilocybin mushrooms may have enhanced pattern recognition, visual acuity, and creative thinking, potentially playing a role in the rapid development of language and abstract thought. While controversial, it reminds us that our relationship with fungi is not just practical but may be woven into the very fabric of what makes us human. Our ancestors walked through the same forests, encountered the same mysterious forms rising from the earth, and wondered, as we do now, at their power and purpose. Our journey through the mushroom kingdom now takes us to some of its most unusual and enchanting corners, where the boundaries between different forms of life blur and blend. There exists a group of fungi called endophytes that live inside plant tissues without causing disease. In fact, they often provide benefits. These fungi live within the leaves, stems, and roots of plants, sometimes producing compounds that make the plant toxic to herbivores or resistant to drought. Some grasses grown for lawns and pastures are intentionally infected with endophytic fungi to make them hardier. The plant provides the fungus with shelter and nutrients. The fungus provides chemical defenses. It's a partnership hidden in plain sight, invisible unless you know to look for it. Now, let's talk about fairy rings, those mysterious circles of mushrooms that appear in fields and forests. For centuries, people believed these rings were caused by dancing fairies or marked places where lightning had struck. The truth is equally magical in its own way. A fairy ring begins with a single spore that germinates and sends out mycelium in all directions equally. As the mycelium expands outward in a circle, it depletes the nutrients at the center and fruits at the growing edge. Some fairy rings are hundreds of years old. The largest known fairy ring, in France, is over 2,000 feet in diameter and estimated to be 700 years old, slowly expanding outward year after year. Here's something that reveals the hidden abundance around us. When you walk through a forest breathing in that earthy, fresh smell, you're actually smelling a compound called geosmin, produced by fungi and bacteria in the soil. This scent is so distinctive that humans can detect it at concentrations as low as 5 parts per trillion. That's roughly equivalent to detecting a single drop in 200 Olympic-sized swimming pools. Our noses are exquisitely tuned to this smell, perhaps because it once helped our ancestors locate water and fertile soil. Mushrooms also have surprising acoustic properties. Some researchers have discovered that the trumpet-shaped chanterelle mushroom can amplify sound. When you whisper into one, it focuses and projects the sound, working much like a megaphone. While we don't fully understand the evolutionary purpose, if any, of this shape, it's a delightful reminder that mushrooms constantly surprise us with unexpected properties. Let's consider the relationship between mushrooms and fire. While fire destroys most living things, certain mushrooms thrive in its aftermath. Morel mushrooms are among the first to appear after a forest fire, sometimes fruiting in enormous numbers in the burned landscape. Some mushroom hunters even follow fire reports, knowing that morels will appear in the spring following a burn. These fungi help forests recover, breaking down the dead wood and preparing the soil for new growth. They turn destruction into opportunity. Here's a fact about mushroom chemistry that seems almost like alchemy. Some mushrooms can accumulate and concentrate minerals from the soil. Selenium, for instance, can be concentrated in mushrooms at levels hundreds of times higher than in the surrounding environment. The same is true for other minerals like copper and zinc. This ability makes mushrooms both valuable as nutritional sources and potentially dangerous if they're growing in contaminated soil, where they might concentrate heavy metals or other toxins. Now, consider the speed of information transfer through mycelial networks. When researchers stimulated one part of a fungal network, they observed electrical signals traveling through the mycelium at speeds of up to 1 millimeter per second. While that might seem slow compared to human neural transmission, remember that these networks can span acres. A signal could travel the length of a football field in just a few hours. The fungal network beneath a forest is constantly alive with these signals, creating a responsive, dynamic system. Mushrooms have also found their way into unexpected technologies. Mycelium can be grown into specific shapes and then dried to create a material that's lightweight, strong, fire-resistant, and completely biodegradable. Companies are now using fungal mycelium to create packaging materials, building insulation, leather alternatives, and even furniture. Some architects are exploring growing buildings from mycelium. Imagine homes that are literally grown rather than built, structures that could be composted when they're no longer needed. Here's something about taste that might surprise you. Mushrooms are rich in glutamates, the compounds responsible for the savory taste known as umami. This is why mushrooms add such depth and richness to dishes. When mushrooms are dried, their glutamate content concentrates, making their flavor even more intense. The Japanese have long understood this, using dried shiitake mushrooms as a fundamental ingredient in dashi, the broth that forms the base of countless dishes. That deep, satisfying flavor you get from mushrooms is chemistry and evolution working in concert. And finally, let's contemplate something truly ancient. Fossilized fungi have been found dating back 460 million years. But the most remarkable fossil discovery came from the Devonian period, around 400 million years ago. Scientists found fossils of organisms called proto-taxites that grew up to 26 feet tall, towering over the small plants of that era. For years, no one knew what these strange pillars were. Finally, analysis revealed they were giant fungi, the largest organisms on land at that time. Imagine a world where mushrooms stood as tall as modern trees, strange spires rising from primordial soil. Those ancient giants are long gone, but their descendants still live beneath our feet. Consider for a moment the resilience of fungal spores. Some species produce spores with walls so thick and protective that they can remain viable for decades, even centuries. Scientists have successfully germinated spores from herbarium specimens over 100 years old. There are documented cases of spores surviving after being frozen, boiled, and exposed to concentrated acids. This extraordinary durability ensures that even in the harshest conditions, fungi can wait, patient and dormant, for the right moment to begin life anew. Mushrooms also engage in chemical warfare with remarkable sophistication. Many species produce antibiotics not just against bacteria, but against other fungi as well. When two different fungal colonies meet underground, they often create a battle zone where both release enzymes and toxic compounds, each trying to defend its territory. Sometimes you can see evidence of these conflicts on the surface, where mushrooms of different species grow in distinct, non-overlapping patches, invisible borders marking ancient underground disputes. Here's something about the relationship between mushrooms and trees that deepens our earlier discussion. Some trees actually rely so completely on their fungal partners that they cannot survive without them. When foresters first tried to transplant certain pine species to new regions, the trees would sicken and die, even in seemingly suitable soil. They eventually discovered that the trees needed their specific mycorrhizal fungi to survive. Now, when transplanting certain species, foresters must inoculate the soil with the appropriate fungi, or the trees simply cannot establish themselves. Let's talk about one of the strangest mushrooms in the world, the zombie ant fungus, Ophiocordyceps. This parasitic fungus infects carpenter ants in tropical forests. Once infected, the ant's behavior changes dramatically. The fungus essentially takes control, directing the ant to climb to a specific height on a plant, bite down on a leaf or stem, and die there. From the ant's head, a mushroom then grows, perfectly positioned to release spores onto the ant trails below, infecting new victims. It's horrifying and fascinating in equal measure, a reminder that fungi have evolved countless strategies for reproduction and survival. Now consider the medicinal potential still being discovered. The turkey tail mushroom, with its beautiful concentric rings of color, has been used in traditional Chinese medicine for centuries. Modern research has confirmed that compounds from this mushroom can boost immune function and may improve outcomes for cancer patients. In Japan and China, extracts from turkey tail are approved as complementary cancer treatments. Clinical trials continue around the world, investigating how these ancient remedies might complement modern medicine. Here's a fact about mushroom cultivation that reveals human ingenuity. The most commonly cultivated mushroom worldwide is the white button mushroom, along with its mature forms, cremini and portobello. They're all the same species, just harvested at different stages of growth. Global production exceeds 10 million tons annually. But cultivation began relatively recently in human history. The first successful cultivation of mushrooms dates to 1650s France, when farmers near Paris discovered they could grow mushrooms in their cave networks. These caves were actually abandoned limestone quarries, and the cool, humid conditions proved perfect for mushroom production. Mushrooms also play unexpected roles in ecosystems as food sources. While we think of deer, squirrels, and other mammals eating mushrooms, they're also crucial food for insects, slugs, and even some birds. The northern flying squirrel feeds almost exclusively on truffles, and these squirrels help spread truffle spores through their droppings. Some beetles spend their entire lives within a single large bracket fungus, eating it, mating in it, and laying their eggs there. The mushroom becomes a complete world for these tiny creatures. Let's explore something about mushroom names and folklore. The fly agaric mushroom, with its iconic red cap dotted with white spots, is perhaps the most recognizable mushroom in the world. It appears in countless fairy tales, art, and popular culture. Its name comes from its traditional use as an insecticide. When broken up in milk, it attracts and kills flies. But this mushroom has also been used ceremonially by indigenous peoples in Siberia for its psychoactive properties. Some scholars even suggest it may be the mysterious soma mentioned in ancient Hindu texts, a sacred substance that provided divine inspiration. Here's something about color-changing mushrooms that seems almost magical. The lobster mushroom isn't actually a mushroom at all, but rather a parasitic fungus that attacks other mushrooms, transforming them completely. It turns the host mushroom bright red-orange and gives it a seafood-like flavor, hence the name. What was once a bland or even bitter mushroom becomes a prized culinary ingredient. It's a transformation so complete that for many years, people didn't realize they were eating a parasite rather than a mushroom species. And finally, consider the remarkable memory-like behavior observed in fungi. Researchers have found that when fungal networks are exposed to stress in a particular pattern, they seem to remember it. When exposed to the same pattern later, they respond more quickly, as if they've learned from experience. This happens without a brain, without neurons, through mechanisms we're still working to understand. It suggests that memory and learning might not require the complex structures we've always assumed were necessary. The mycelium beneath the forest floor may be recording experiences, adapting, and in its own way, remembering the patterns of the world above. As we continue our exploration, let's discover how mushrooms weave themselves into human economies, culinary traditions, and the delicate balance of ecosystems. Truffles, those mysterious underground mushrooms, command some of the highest prices in the culinary world. The white truffle from Alba, Italy, can sell for thousands of dollars per pound, with individual specimens sometimes fetching over $300,000 at auction. What makes them so valuable isn't just their intense, complex aroma, but their scarcity and the difficulty of cultivation. Despite decades of attempts, white truffles still resist most efforts to farm them reliably. They grow only in specific conditions, in partnership with certain trees, in particular types of soil. They must be hunted with trained dogs or pigs, harvested by hand, and sold fresh within days. It's a tradition stretching back centuries, unchanged by modern agriculture. Here's something about mushrooms and water that reveals their crucial ecological role. Mycelium doesn't just grow through soil, it holds soil together. The networks of fungal threads bind soil particles, reducing erosion and helping soil retain water. In fact, soil with healthy fungal networks can hold up to 8 times more water than soil without fungi. In an age of increasing droughts and water scarcity, these underground networks may be more important than we ever realized, quietly managing water resources beneath every forest and field. Now let's talk about bioluminescent mushrooms again, but from a different angle. Scientists believe these mushrooms glow to attract insects in the darkness. The light draws in beetles, flies, and other insects, which then carry spores on their bodies to new locations. It's a brilliant solution to the challenge of spore dispersal in the dim understory of tropical forests. The mushroom creates its own beacon, advertising its presence in the dark, turning night into an opportunity rather than an obstacle. Consider the matsutake mushroom once more, but now its cultural significance. In Japan, matsutake holds a revered place in autumn cuisine, symbolizing the changing season. The tradition of matsutake hunting is so important that people take time off work for it. Families pass down secret hunting locations through generations, and the first harvest of the season makes national news. The mushroom's spicy, earthy aroma evokes autumn itself for many Japanese people. It's a reminder that mushrooms aren't just food or ecological players, they're woven into cultural identity and seasonal rhythms. Here's a fact about fungal diversity in surprising places. The extreme environment of Antarctica might seem lifeless, but fungi thrive there. Scientists have discovered hundreds of fungal species living in Antarctic soil, rocks, and even inside sandstone. These extremophile fungi can survive temperatures far below freezing and can remain dormant for extended periods, springing to life during the brief Antarctic summer. Some produce antifreeze-like compounds that prevent ice crystals from forming in their cells. They represent life's tenacity, persisting in one of Earth's harshest environments. Mushrooms also have fascinating relationships with light beyond bioluminescence. Some mushrooms track the sun, a behavior called phototropism. Their caps turn to follow the light throughout the day, maximizing the dispersal potential of their spores on air currents warmed by sunshine. Others release their spores in the early morning, when temperature differences create updrafts that carry spores high into the atmosphere. Every detail of their structure and behavior has been refined by evolution to solve the eternal challenge of reproduction and dispersal. Let's explore something about cooking and chemistry. When you cook mushrooms, they release water and shrink dramatically, sometimes by 70% or more. This is because their cell walls, made of chitin, the same material in insect exoskeletons, break down with heat. Cooking also makes mushrooms more digestible for humans and unlocks flavors trapped within their cells. Many mushrooms are toxic or indigestible when raw but become perfectly safe and delicious when cooked. This transformation through fire has been understood by humans for millennia, turning tough fungi into tender, savory morsels. Here's something about mushrooms and their role in fermentation. While yeasts, which are single-celled fungi, are famous for their role in making bread, beer, and wine, other fungi are equally important in fermentation. The mold Aspergillus oryzae, called koji in Japanese, is essential for making sake, miso, and soy sauce. It breaks down rice and soybeans into simpler compounds, creating complex flavors in the process. In China, it's been used for over 2,000 years. Without this humble fungus, much of East Asian cuisine as we know it wouldn't exist. Now consider something about mushrooms in architecture, beyond just mycelium building materials. Traditional Japanese temples use a preservation technique where they place specific fungi on wooden beams. These fungi create a protective coating that prevents more destructive species from taking hold. It's biological protection, using one fungus to defend against others, a technique passed down through generations of temple builders. The ancient wood endures, sheltered by microscopic guardians. And here's a final thought for this segment about mushroom hunting traditions around the world. In Eastern Europe, mushroom foraging is a beloved cultural practice. Entire families venture into forests each autumn, guided by knowledge passed down through generations. There are regional competitions, local festivals, and a deep pride in knowing the forests and their fungal inhabitants. In Poland, it's estimated that over 90% of the population forages for mushrooms at some point in their lives. It's not just about food, it's about connection to the land, to tradition, and to the changing seasons. These traditions remind us that our relationship with mushrooms is ancient, intimate, and ongoing. As we near the final stretch of our journey, let's delve into some of the most intriguing mysteries and recent discoveries about these remarkable organisms. There's a phenomenon in nature called mushroom stones, ancient artifacts found throughout Mesoamerica that date back as far as 3,000 years. These carved stone sculptures depict mushrooms with faces or figures beneath their caps, suggesting that mushrooms held profound spiritual significance in these ancient cultures. Found primarily in Guatemala and Mexico, they provide tangible evidence of humanity's long relationship with fungi, particularly those used in sacred rituals. These stones were important enough to be crafted, preserved, and sometimes buried with the dead, indicating that mushrooms were seen as bridges between worlds. Here's something about the peculiar nature of fungal genetics. Fungi can have not just two mating types, like male and female in many organisms, but dozens or even thousands. Some species of mushrooms have over 20,000 different mating types. Any two individuals of different mating types can reproduce together, which dramatically increases genetic diversity. This system ensures that fungi can adapt quickly to changing environments, mixing and matching genetic material in ways that would be impossible for organisms limited to just two sexes. Consider now the curious case of the desert truffle. While we often associate mushrooms with damp forests, some species have adapted to arid environments. Desert truffles have been harvested for thousands of years in the Middle East and North Africa, appearing after winter rains in seemingly barren landscapes. They form partnerships with desert plants, helping them survive in harsh conditions. Bedouin peoples have long known where and when to find them, reading the subtle signs in the landscape that indicate truffles growing beneath the sand. Let's talk about something called mushroom leather, or mycelium leather. Companies are now growing sheets of mycelium that, when processed, have the look and feel of animal leather but are entirely fungal. This material can be produced in weeks rather than the years needed to raise livestock, uses a fraction of the resources, and is completely biodegradable. Fashion designers are already creating bags, shoes, and garments from this material. It's one more way that fungi offer sustainable alternatives to resource-intensive industries. Here's a fact about mushrooms and sound that goes beyond the chanterelle's acoustic properties. Some researchers have experimented with connecting fungal mycelium to electronic sensors and speakers, translating the electrical signals in the mycelium into audible sounds. The result is an eerie, unpredictable soundscape that changes based on the fungus's activity and environment. While we can't claim this is music in the way the fungus experiences it, if it experiences anything at all, it gives us a new way to perceive the constant activity happening beneath our feet. Now consider the reishi mushroom, known in China as the mushroom of immortality. It has been used in traditional medicine for over 2,000 years, believed to promote longevity and vitality. Modern research has found that reishi contains triterpenes and polysaccharides that may have anti-inflammatory and immune-modulating effects. While it won't grant immortality, studies suggest it may indeed support health in measurable ways. It's a reminder that traditional knowledge often contains genuine wisdom, waiting for modern science to understand the mechanisms. Here's something about the sheer speed of fungal evolution. Because fungi reproduce so rapidly and generate such enormous numbers of spores, they can evolve resistance to antifungal drugs within years or even months. This is becoming a serious medical concern, as drug-resistant fungal infections are on the rise worldwide. The same adaptability that allows fungi to thrive in diverse environments also allows them to evade our attempts to control them. It's an ongoing evolutionary race, with fungi demonstrating nature's relentless drive to survive and adapt. Let's explore the role of mushrooms in traditional dyes. Before synthetic dyes became common, mushrooms were valued sources of color. Different species can produce yellows, oranges, reds, greens, blues, and purples. The dyes are often remarkably light-fast and color-fast, resisting fading over time. Some indigenous cultures still use mushroom dyes for traditional crafts. It's yet another gift these organisms provide, having evolved pigments for their own purposes that happen to be useful for ours. Here's a fascinating fact about fungal consciousness, or at least, what might be considered a form of awareness. Studies have shown that when mycelium encounters food sources, it sends out exploratory branches in multiple directions. If a branch finds food, the network redirects resources toward that branch, strengthening it. If a branch finds nothing, those resources are withdrawn. This is decision-making, a form of information processing that allows the fungus to efficiently explore its environment. Some scientists argue this represents a distributed form of intelligence, neither conscious in the way we are, but also not purely mechanical. And finally, consider the ghost fungus of Australia, another bioluminescent species, but one surrounded by particular folklore. Aboriginal Australians traditionally believed these glowing mushrooms marked the locations of spirits. In the darkness of the Australian bush, finding these ethereal green lights must have seemed like encountering something from another realm. Modern visitors still seek them out, hiking into the forests at night to witness their gentle glow. It's a reminder that mushrooms occupy a space in human imagination that goes beyond biology, touching something deeper in our relationship with the natural world and its mysteries. As we approach the final chapter of our journey, let's explore how mushrooms continue to inspire innovation and reveal the profound interconnectedness of all life on Earth. Let's begin with something that bridges ancient tradition and modern science. The chaga mushroom, which grows as a dark, crusty mass on birch trees in cold climates, has been used in folk medicine across Russia and Northern Europe for centuries. It was brewed into tea to treat various ailments. Recent research has found that chaga is extraordinarily rich in antioxidants, containing some of the highest levels ever measured in natural foods. While more research is needed to fully understand its effects, it demonstrates once again how traditional remedies often point us toward genuine biological activity. Here's something about mushrooms and textiles beyond leather. Scientists are now developing fabrics where living mycelium is integrated into the material itself. These living textiles can potentially sense and respond to their environment, self-repair small damages, and even change their properties based on conditions. Imagine a jacket that adjusts its insulation based on temperature, not through electronics, but through living fungal networks woven into its fabric. It sounds like science fiction, but prototypes already exist. Consider now the cordyceps mushroom, another fungus famous for its parasitic lifestyle, though not the zombie ant variety. Ophiocordyceps sinensis, the caterpillar fungus, infects ghost moth larvae in the high plateaus of Tibet and the Himalayas. It has been used in traditional Tibetan and Chinese medicine for centuries and is so highly valued that it can sell for more than its weight in gold. Harvesters trek through harsh mountain terrain at altitudes above 12,000 feet to collect it. It's become such a valuable commodity that it provides significant income for rural communities, though over-harvesting has raised conservation concerns. Here's a fact about mushrooms in space exploration. NASA has been researching whether fungi could be used to build structures on Mars or the Moon. Mycelium could potentially be grown using local materials and waste products from astronauts, creating building blocks, insulation, or even air filtration systems. The fungus would grow the structure, then be dried or killed to create a stable material. It's an elegant solution to the challenge of construction in space, where every kilogram of material transported from Earth comes at enormous cost. Let's talk about the chicken of the woods mushroom, named for its texture and flavor that remarkably resembles chicken when cooked. This bright orange and yellow shelf fungus grows on trees and has been enjoyed as food for generations. But here's what makes it particularly interesting. It's one of the few mushrooms that can serve as a convincing meat substitute even for dedicated carnivores. As the world seeks more sustainable protein sources, mushrooms like this offer not just nutrition but genuine culinary satisfaction, textures and flavors that need no apology or comparison. Now consider something about mushrooms and pharmaceutical manufacturing. Beyond the drugs derived directly from fungi, mushrooms are also being used as living factories to produce other medicines. Scientists can genetically modify fungi to produce specific compounds, from human proteins to complex pharmaceuticals. Fungi are ideal for this purpose because they grow quickly, are easy to work with genetically, and can produce complex molecules that would be difficult or impossible to synthesize chemically. It's biotechnology built on millions of years of fungal evolution. Here's something about the ecological cascade effects of losing fungal diversity. When certain mycorrhizal fungi disappear from an ecosystem, the trees they partnered with often decline, even if the environment seems otherwise suitable. This affects the animals that depend on those trees, the insects, the birds, the entire community. Scientists are increasingly realizing that fungal diversity may be just as crucial to ecosystem health as plant or animal diversity, yet fungi receive far less attention in conservation efforts. Protecting forests means protecting not just the trees we see, but the fungal networks we don't. Let's explore something whimsical yet scientifically intriguing. There's a mushroom called the bleeding tooth fungus, or devil's tooth, that produces bright red droplets on its white surface that look remarkably like blood. This liquid, called guttation, is actually the mushroom exuding excess moisture containing various compounds. Research has found that this species produces compounds with anticoagulant properties similar to those found in medical blood thinners. Nature's dramatic presentation hiding practical chemistry once again. Here's a fact about fungal communication that expands on what we've discussed. Recent studies suggest that the electrical signals traveling through mycelial networks might constitute a kind of language. Researchers analyzing these signals found patterns resembling linguistic structures, with up to 50 distinct words based on signal patterns. Whether this represents true language or simply complex signaling is still debated, but it suggests that the conversation happening beneath the forest floor is far more sophisticated than we imagined. And finally, consider the artist's conch, a bracket fungus with a smooth white surface that darkens when touched or scratched. Artists have used this mushroom as a natural canvas for centuries, etching drawings that become permanently darkened. Indigenous peoples of the Pacific Northwest created intricate designs on these fungi. Today, artists continue this tradition, creating detailed artwork on these living canvases. When dried, the images remain preserved indefinitely. It's art and nature collaborating, the mushroom providing the medium, the human providing the vision, creating something neither could achieve alone. As we approach the end of our journey through the world of mushrooms, let's contemplate some final wonders that bring our story full circle and remind us why these organisms continue to captivate our imagination. Think for a moment about the honey mushroom we mentioned earlier, that vast organism spreading through the Oregon forest. But here's another remarkable fact about it. This single fungus isn't just large and old, it's also a pathogen that can kill trees. Yet its presence isn't entirely destructive. By creating gaps in the forest canopy when trees die, it allows light to reach the forest floor, enabling new growth and maintaining forest diversity. Even a killer can be a gardener, shaping the landscape in ways that ultimately support more life. Nature rarely deals in simple categories of good and evil. Let's talk about something called fairy butter, or witch's butter. This isn't actually a mushroom in the traditional sense, but a jelly fungus that appears as bright yellow or orange gelatinous masses on dead wood, especially after rain. In folklore, these strange blobs were thought to be left by fairies or to be omens of witchcraft. The reality is no less interesting. These fungi can survive nearly complete dehydration, shriveling to almost nothing in dry weather, then swelling back to life when moisture returns. They're masters of resilience, demonstrating that survival sometimes means knowing when to retreat and when to expand. Here's something about the relationship between mushrooms and ants that goes even deeper than the leafcutter example. Some ants don't just farm fungi, they've been doing it for so long that the fungi they cultivate can no longer survive in the wild. And the ants, in turn, have lost the ability to digest anything except their fungal crops. They're locked in an evolutionary embrace, each species completely dependent on the other. It's mutualism taken to its ultimate conclusion, two life forms becoming essentially one system. Consider now the peculiar world of lichens, which aren't mushrooms but are partnerships between fungi and algae or cyanobacteria. The fungus provides structure and protection, while the photosynthetic partner provides food. Lichens can survive in environments where neither partner could live alone, from Arctic tundra to desert rocks to urban concrete. They're among the oldest living things on Earth, with some specimens estimated to be thousands of years old. They grow so slowly that some Antarctic lichens add less than a millimeter per century. They remind us that life finds ways to collaborate, creating new possibilities through partnership. Here's a fact about the economic impact of fungi that might surprise you. The global mushroom industry is worth tens of billions of dollars annually, but crop-destroying fungal diseases cost even more. Fungi cause billions of dollars in damage to agriculture every year, attacking crops from wheat to coffee to bananas. The same versatility that makes fungi so successful also makes them formidable agricultural pests. We exist in constant negotiation with fungi, trying to cultivate the helpful ones while defending against the destructive ones, a balance as old as farming itself. Let's talk about something called mycophobia, the fear of mushrooms. While many cultures embrace mushroom foraging as we've discussed, others, particularly in English-speaking countries, have historically been more suspicious of fungi. This might stem from the genuine danger of poisonous species, or from cultural associations between mushrooms and death and decay. Yet this fear is gradually giving way to fascination as people discover the culinary, ecological, and scientific wonders of fungi. We're living through a renaissance of mushroom appreciation, rediscovering knowledge that other cultures never lost. Here's something about mushrooms in mythology and religion beyond what we've mentioned. In Siberian shamanic traditions, the fly agaric mushroom was considered a gift from the gods. When reindeer ate these mushrooms, their urine retained the psychoactive compounds but filtered out some of the more toxic elements. Shamans would sometimes drink this urine as part of their spiritual practices. Some scholars have even suggested that this tradition, combined with flying reindeer and a figure in red and white, might have influenced modern Santa Claus imagery. Whether or not this connection is real, it reminds us how deeply mushrooms are woven into human storytelling. And here's our final ecological fact before we conclude. Mushrooms are among the few organisms that can break down microplastics, those tiny plastic particles that now permeate our environment. Certain species produce enzymes capable of degrading plastic polymers, potentially offering a solution to one of our most pressing environmental challenges. Research is still in early stages, but fungi may once again prove to be nature's clean-up crew, capable of addressing problems that seem insurmountable. They've been decomposing the world for 1 billion years. Perhaps they can help us decompose our mistakes too. As we reach the end of our time together, take a moment to reflect on everything we've discovered. Mushrooms are ancient and modern, massive and microscopic, dangerous and healing, alien and familiar. They've shaped our planet's ecosystems, influenced human culture, and continue to surprise us with new possibilities. The next time you see a mushroom pushing up through soil or sprouting from a fallen log, remember that you're glimpsing just the smallest part of something vast and mysterious, a kingdom of life that existed long before us and will likely persist long after. These quiet, often overlooked organisms are fundamental to life on Earth, connecting everything in ways we're only beginning to understand. Thank you for walking this path through the world of mushrooms. May you never see them quite the same way again.